Hello everyone, this is the demonstration phase of the example code RC Smart Avoider. The goals for this program is to show you how to mix remote control and autonomous behavior. Also how to show how to use the motion pages, so-called 0 and -1. It is related to exit motion units also, and also show you how to use the callback function. The callback function is executed every 8 milliseconds. To be exact, 7.8 milliseconds, but we'll round it up. And in the callback that I use in this example, every time we go through there, it just pick up the IR sensor number 1, save it into a parameter NIR left, pick up port 4 IR sensor and save it into parameter NIR right. And then from then on, anywhere else in the program, whether it's from the main program or from any of the function inside this code, anytime you use a parameter NIR left, you're guaranteed to have at most a value from the IR sensor at port 1 only about 8 milliseconds old. Okay, so it gives you the fresher data, and it uses hardware, so you don't even have to worry about coding it in. So that's a nice feature about callback. In the book, it shows more detail about the certain restriction on how you can use a callback. You cannot just program it as any other function. How does it do for obstacle detection? So the idea of this code is, while under the remote control, and let's suppose, for example, when you drive against a wall, like for example, how can the obstacle detection? Because it's using 2 NIR sensor, so we know it can detect whether it's a frontal obstacle, that means straight on, or it could be kind of slanted, like in this case here, the obstacle is more on the left. Okay, so therefore you know these basically 3 cases, frontal object, left obstacle, or right obstacle, and you can see you can define the proper, shall we say, evasion maneuver depending on the situation. So what it does is, the way that we want to mix RC and autonomous function is, let's say the operator drive this robot straight to the wall, like in this case here. Once it detected that the obstacle is close enough to a certain threshold, it will ignore the remote control of the operator. That means the operator can still push the up button, make it drive it forward toward the wall, but the robot will take over and will try to avoid it until it's clear again, and then it releases back the RC control back to the human operator. Okay, so we have 2 algorithms shown in the book. Basically, the first algorithm is you check on the remote control whether it's something new thing coming in or not. If you're in, and then you process it. If it's released or if nothing, and then the robot is going to initial position. Else, that means that you push up, down, left, right data coming in, and then you check first to see if there's no obstacle detected by the left or the NIR left or NIR right, and then you execute the proper remote control as normal. Else, that means there's some obstacle detected, and then you stop the robot. You need to figure out, the robot needs to figure out whether the obstacle is frontal, left, or right robot, and then activate the obstacle robot avoid and move until obstacle is clear of the NIR sensor. This is important because the way design is, I want the robot to get clear of the obstacle within the same iteration of the main endless loop. Once that's done, and then can use LED to flash the signal successful avoidance of the obstacle. And then also there's special software to wait until the operator relieves the last RC button, which made the robot walk into the obstacle in the first place, and then it's loop again. So once it's clear, it lets the operator play with the robot again. So this algorithm 1, essentially, it starts by checking on the remote control data coming in first, and then it checks on the obstacle. In algorithm 2, you check the obstacle first. If it's clear, and then you pick up and process the remote control data. Else, basically the same thing. Stop the robot, figure out what kind of obstacle are we dealing with? Frontal, left, or right? And then get away from it, flash the LED, wait until the operator release the RC button. Okay, but you can see that this one, in a way, you can read it cleaner. You can see the RC path right here, and then you see the autonomous path right here. Okay, so like this one here is algorithm 2, the code here exactly. So see line 15 here, when everything is clear, there's no obstacle, you go in and process the remote control data, and it does its stuff. Else, this is the autonomous path, it had to avoid the obstacle. Okay, so practically correspond into the, shall we say, the physical flow diagram of the sensing act. Last one is how does the robot stop? And this takes some more doing. I think suppose you just pushed up, so the advanced motion plays being played. And in the book it's explained also, the motion plays, when you put advanced, it actually activate the link motion unit, advanced 1.1b. So you keep on doing that. Okay. And then they also we define the book advanced 1.2b, which is called the exit MU. Basically, it's gonna put its leg together and lined up. So when you stop the robot, that two ways to stop the robot with ROBOTIS software. You can send and make it play motion index 0. When you do this, it will make the robot goes to the end of motion unit 1-1-B. If you send up a -1 and try to play motion index -1, it will switch to the exit MU motion unit and go to the end of the advanced 1-2-B motion unit. Okay, so that's two ways to do it. It depends on whether you define your exit MU or not, or you just usually most people just use a link MU, that's all. But this is a nice feature to recover from emergency or regular stop. So let's see how it goes. I already downloaded the code for it. The remote control is here. I think it's still connected. And the robot is here. Let me check to see it's working. Okay, here we go. It works. Okay, so I'll make it to the left a little bit, and I'm gonna just drive us against the wall. So I'm still pushing on the up button here, but you can see the robot cleared it out of the wall by itself. But it didn't turn right very well. Let's see. Can you? Okay, highly clear. It flashes a LED, but because I'm still pushing on the up button here, you can see. I've been pushing it all the time, so it just stopped it. Now I'm going to release it. Now I can make it go. One problem I have is supposedly those LEDs are supposed to be turned off, but somehow they still stay on. Now I just lost all my data, so it gets stuck here. Okay, I'm coming back to it and save. So I'm going to turn to the left, go backward a little bit. Let me drive it so that it access the left now. So okay, go straight in. See, it's avoiding. Suppose it lasts 4 times and it's turn off the LED, which is correct now. I'm going to turn right, so you see it's right under the right control. Move back a little bit. Make it turn right. So facing that way. Go forward. See, can we clear it? Here we go, finally clear. But this time it also turned off the LED. Okay.